Welcome back to The Explainer. Okay, I am absolutely thrilled to have you here today because we're going to do something I just love. We're uncovering brilliant engineering that is literally hiding in plain sight. Often the most profound design achievements aren't locked away in some high-tech lab somewhere. They're sitting quietly right in our homes. Today, we're taking a deep dive into a completely mundane kitchen tool, the humble apple slicer. So let's jump right in and see how a literal masterclass in mechanical design is just waiting for us in our kitchen drawers. So how much engineering actually goes into your afternoon snack? It's a question we almost never stop to ask, right? Think about it. When you reach for a piece of fruit, you just want to eat it. And let's be honest, sometimes just the sheer laziness of having to actually prep a snack is enough to make us grab a bag of chips instead. We all experience that everyday friction in the kitchen, those annoying little obstacles between us and our food. But what if getting past that friction required a perfectly calibrated physical intervention? Like, how much structural engineering is really required to turn a round, totally irregular piece of fruit into a perfectly portioned snack? Well, just look at this. Symmetry in seconds. In one single, fluid downward motion, an entire apple is completely transformed. Boom! You get these perfectly uniform pieces of fruit, resting elegantly on the very metal blades that just cut them. There's no messy cutting board, no weird uneven chunks. It's an instant transformation from a whole object to a precisely sectioned grid, and it all happens in mere seconds. Section 1. The perfect slices. 8. That is the exact number of uniform wedges this tool creates all at once. And quantifying this really reveals the genius here because producing 8 identical pieces of anything by hand, that is a painstaking task. It takes measuring, adjusting, and repeating. But here, that number 8 is completely guaranteed by the physical constraints of the tool itself. You literally don't even have to think about it. The math is built right into the metal. And then, on the flip side of those 8 wedges, we have the number 1. This is that single, neatly isolated core. The brilliance of this is that the tool doesn't just divide the apple up, it categorizes it. It separates the edible parts from the inedible parts in the exact same motion you use to portion the fruit. It leaves us with exactly one single piece of waste, perfectly separated from the snack we actually want to eat. Now notice how the red skin of the apple holds its shape perfectly across every single one of those 8 wedges. Look at those really crisp edges where the yellow flesh meets the skin. I mean, this isn't a crushed or torn apple. It is cleanly sliced. And that just proves the clean, sharp cut of the stainless steel. The structural integrity of the fruit is totally maintained because those blades are sharp enough and thin enough to pass right through the flesh without causing any collateral damage. All right, moving on to Section 2, Anatomy of the Slicer. We can basically deconstruct this tool into 3 main parts. First, you've got the outer metal frame and base. Second, those 8 radial cutting blades that are doing the actual dividing. And third, the central coring ring right at the heart of the mechanism. These 3 distinct parts work in total, perfect unison to get the job done. But the really crucial point here is this outer perimeter. That wide, unified metal frame doesn't just hold the blades in place. It actually serves as the handles. By extending the metal outward on both sides, the tool is specifically designed to evenly distribute the downward force you're applying with your hands. You press down on those wide, flared sides, and that force is channeled perfectly, completely evenly across the entire network of blades below. It's basically a lever system that completely maximizes your human effort. Section 3. The geometry of wedges. So let's think about the actual physical process here. Step 1, you center that inner ring perfectly right over the apple's stem. Step 2, you apply that even downward pressure onto the wide base we were just talking about. And step 3, you push straight through until the blades hit the cutting board. The geometry of the tool literally forces the user to follow these exact steps. It guides you, ensuring a perfect result every single time you use it. Which naturally brings up a totally fair question. Why use a dedicated tool for this at all? I mean, humanity has been slicing fruit for thousands of years before this specific gadget even existed. So what makes this piece of metal so incredibly valuable that it deserves prime real estate in our kitchens? Well, the true value becomes super obvious when we compare it to the alternative, right? The traditional knife method. With a knife, you're making multiple cuts, you're almost guaranteed to get uneven pieces, and let's face it, there is always a genuine fear of slicing your fingers every time you chop toward a slippery, wet, rounded core. But with the slicer method, it's one single motion. It yields absolutely perfect symmetry, and your hands stay safely up on that outer frame, far, far away from the sharp edges doing the cutting. It's a massive upgrade in efficiency, aesthetics, and for sure, safety. Section 4. Isolating the core.
If you look dead center, there's a yellow cylinder of apple, trapped perfectly within that central metal ring. This is just a masterpiece of precision. By creating a continuous circular blade in the middle, the tool totally isolates the seeds, the tough inner casing, and the stem. It literally builds a wall between the parts of the apple you want to eat and the parts you definitely don't.
And this brings us to a really key concept: radial design. Radial just means arranged like rays, or the radii of a circle, diverging from a common center. That radial layout of these 8 blades intersecting with the center ring is exactly what dictates the precise geometry of the cut. The blades all originate from that central ring and fan out to the base. This guarantees every slice is exactly the same angle and perfectly separated from the core in one single smooth stroke.
Which brings us to Section 5, the beauty of utility. There is a very famous design principle: form follows function. And here, form perfectly follows function in one singular, efficient motion. Tools designed for a singular, highly specific purpose just feel deeply satisfying to use and even to look at because there are absolutely no compromises. A Swiss Army knife is great because it can do 20 things pretty decently, but an apple slicer, it's beautiful because it does exactly one thing completely flawlessly.
This really is a case of finding the extraordinary right there in the ordinary. What just appears to be a simple piece of kitchen plastic and metal is actually a marvel of functional design. It's an artifact dedicated to eliminating everyday friction. It takes this irregular product of nature and uses geometry, physics, and metallurgy to instantly optimize it for human consumption. It's kind of amazing when you really think about it. So I want to leave you with a final thought to ponder today. Look around your own environment. What other single-purpose tools perfectly solve a daily problem in your kitchen? Because I promise you, once you start looking for the quiet genius in everyday objects, you're going to see brilliant engineering absolutely everywhere. Thank you so much for exploring this with me today. Keep asking those questions, and I will catch you in the next explainer.